Hey everybody, and welcome back to our lesson on section 3.1 in the book. So continuing on, I'm looking at example 6 here in that section, and this is very similar to what we were talking about in the last video. So I have both sides of this equation graphed out here. So I have this line here and then this dotted line here. Those are the two that I'm looking at. So what is their point of intersection? Their point of intersection would be 2, 0. And so if I wanted to use this point then to figure out what is the solution to 3x minus 6 equals 0, I would say that my solution, my solution is x equals 2. Now, just to be thorough like we were in the last video, what I want to do is now I want to actually solve this equation. So I've got 3x minus 6 equals 0. Let me add 6 to each side, so I get 3x equals 6. Divide each side by 3, and I get x equals 2. So hey, that totally worked, right? So this is what we've been talking about so far in this section. But this point in particular and how this line crosses kind of this particular area, this is a unique thing. This is a thing. So what I want to point out here is this line here. What is this line? This line is actually, this is the x-axis. And so when you have a line or, a graph crossing the x-axis, those points where it intersects, it could be the solution to this equation here, but this is also what's known as the X-intercept. So I'm going to introduce now kind of a different concept. So the X-intercept, it's very simple. It's the point where a graph intersects the x-axis. And it is a point. It's not technically a solution, but we can leverage it to make a solution. So what I want to do is I want to talk a little bit more about the x-axis. So let's go to the next page. And you can see here, so I've got these 3 graphs. I want you to pause the video and just circle all the places where you see x-intercepts on the 3 graphs and hit play when you're ready. Okay, so looking at this first graph, I see 3 points of intersection, right? 3 places where it crosses the x-axis. This dark line is supposed to be the x-axis. And then on this next graph, just here, and then on this last one, I see these 2 areas where it crosses. Now, what I want you to do is think for a second. This is not going to be totally obvious at first. In looking at this, what do you notice in common about the y coordinate of all of these points? So I want you to actually pause and think about this for a second. So the y coordinate for each of these, if I'm crossing the x-axis, the y coordinate is actually equal to 0. So what that means is x-intercepts have the form. They have this form like this like point, whatever you want to put in here, but also the y coordinate of this point will always be 0. So you can relate this back to equations in that this is actually how you find a solution for an equation that is equal to 0. So I know this is kind of a weird thing to talk about, so I'm going to now spend some time showing you a few examples of this. So let's go down here to example 7. So I have a function here graphed, f of x, and for now, it totally doesn't even matter what this equation is. I don't even want you to worry about that. I just want to kind of show you how do we actually leverage this concept of x-intercepts. So the first thing I want to do is I want you to identify what the x-intercepts are. So in this case, it's these 3 points here. And what are those 3 points? Well, this is the point -2, 0, -1, 0, and 1, 0. Those are my x-intercepts. And so with this, we can actually solve a particular equation. So like I said, I don't know what the graph of this line actually is. We are just calling it something general, f of x. So I'll just draw a little line saying this is f of x. But the one thing that I could actually set up here, I can say that the equation f of x, whatever that is, I know how to solve it when it's equal to 0. I know how to solve it. The solutions are x equals -2, x equals -1, and x equals 1. Those would be my 3 solutions. to this equation. And so this is the structure that I want to think about for the next few examples. So let's take a look at another one. Moving on to the next page. The first thing that I want you to do is pause the video and just identify what is the x-intercept. So the x-intercept here is just the point 3, 0. That is the x-intercept. Now the second part of this is what equation can we solve using that information? Well, in this case, I know what my f of x is. It's this equation, so I have a little bit more information. So what I know is that I can set that equation, 3x plus 2 minus 5x plus 4, I can set that equal to 0, and I should know the solution to this. The solution to this should be x equals 3. So that's the information that you get out of this. So like I said, this is a little bit different from probably something you've seen in the past, but that's okay. We can totally still do this, right? So what I want to do is I want to actually convince you of this in case you're a little skeptical. So I want you to take this and I want you to solve this equation below and then hit play when you're ready. Okay, so I'm going to go ahead and work on this. So I get negative 2x plus 6 equals 0 if I collect my like terms. I'll subtract off my 6, so I get negative 2x equals negative 6. Divide both sides by negative 2, and I get x equals 3. Okay, so I got x equals 3. Going back up here, that is exactly what I thought the solution was going to be, right? So we are getting particular information out of these points that we, like I said, we are leveraging it to help us solve equations. So it's something a little different from how we've looked at graphs in the past. Okay. So now I want to go to the next page, example 9, and I think you kind of have the idea behind this. So what I want you to do is find your x-intercept and then determine what equation is being solved in this situation, what should the solution be, and then I want you to prove it to yourself by actually doing it all below. So I want you to try to do this whole thing on your own and hit play when you're ready. So here my x-intercept is negative 1, 0. So then what that means is I've got this 3 plus 5x minus 1 minus 3x. I should be able to set this equal to 0, and then the solution is x equals negative 1. So now what I want to do is I just want to solve this below. So let's see, I'll write this out. 3 plus 5x minus 1 minus 3x equals 0. So let me give myself some space. And so now let me solve this. So 3 minus 1 is 2. 5x minus 3x is going to give me 2x. Now I can subtract off the 2x and divide each side by 2, so I get x equals negative 1. Does that match what I had up above? It does. So you can see here that this is just a different way of looking at this information, and it is very powerful. So I'm going to stop the video here. This is where we'll pick up in the next video. This video is already getting to be a little bit long, so I'll see you guys in the next one. Thanks for watching.